Good day. Today I will be presenting part 2 of my cybersecurity chatbot, Maven. As we still know, cybersecurity threats in South Africa are still on the rise and are very prevalent in the digital world today. Pressing issues such as phishing and malware attacks are becoming more sophisticated and more dangerous, all while 70% of South African organizations lack basic cybersecurity awareness. Since presenting part 1, I have added a number of key improvements, such as keyword recognition, random responses, enhanced conversation flow, memory recall, and sentiment detection. I created a tip of the day feature where tips are stored in a dictionary and are displayed randomly before the user is asked to put their name in. I created a more interesting way of greeting the user by storing different greetings in a dictionary and randomly selecting one to greet the user. Beginning with keyword recognition, I have integrated keyword recognition in my code by using a dictionary named responses, where each key is a topic, like phishing, and the value is an array of possible chatbot replies related to that topic. The for each loop then checks if the user's input contains any of the topic keywords from the dictionary. If a match is found, it sets detected topic to that keyword for further response handling. To ensure the chatbot chooses random responses from the dictionary of responses, I have used a random object named RND to select a random response from the array of replies associated with the detected keyword in the responses dictionary. It then changes the console text color to white and outputs the randomly chosen reply using the type response method. I have created a follow-ups dictionary to allow the chatbot to ask users follow-up questions to allow a more natural conversation. This dictionary stores follow-up questions related to each topic. For example, if the topic is phishing, the chatbot might ask, "Have you ever received a suspicious email or message?" The if statement part checks if the chatbot is not waiting for a follow-up response and not currently in conversation. If both are true, it changes the text color to cyan and prompts the user with a friendly message asking how it can assist. This section of the while loop allows the chatbot to provide more details on the current topic the user is interested in. If there is a current topic and the user includes phrases such as explain, more, I don't understand, or what do you mean, the chatbot picks a random extra response from the responses dictionary for that topic. Then it sends a message offering more information about the topic followed by a deeper explanation. Then it immediately waits for the next user input. Continue skips the rest of the loop. The chatbot then handles follow-up responses by doing the following. If the chatbot is waiting for a follow-up response, awaiting follow-up response, and the user says yes, confused, explain more, I don't understand, it replies with another random tip about the last follow-up topic. Then it moves to the next follow-up question in the sequence. If there are more follow-up questions, it asks the next one and stays in the conversation. If not, it asks if the user wants to explore another topic. It keeps awaiting follow-up response true only if more follow-ups remain. If the user says no, it ends the follow-up conversation, resets relevant flags, counters, and offers to help with something else. When the chatbot already knows the current topic, i.e. current topic is not null, and the user asks for more details or clarification by including words such as explain, more, I don't understand, or what do you mean in their input, it retrieves the list of responses related to the current topic from the responses dictionary. It picks a random response from the list to give a deeper additional explanation. It sends a message saying it will provide more information about the current topic and sends the randomly selected deeper response. The chatbot then skips the rest of the loop and waits for the user's next input using continue. For memory and recall, I have used a check for keywords method to detect when a user expresses interest in a specific cybersecurity topic. It works by scanning the user's input for keywords that show curiosity or concern, like interested, worried, or fascinated, and matches this with a list of predefined cybersecurity topics, such as malware, phishing, or ransomware. If both an interest keyword and topic keyword are found in the input, it stores the topic in a memory list, remembered topics, so the chatbot can recall it later in the conversation. It also sets a flag to indicate that the user has shown interest and resets a prompt counter, which helps the chatbot decide to naturally bring the topic back up. Additionally, it provides a personalized response acknowledging the user's interest, helping to create a more engaging and context-aware interaction. This if statement allows the chatbot to perform the recall. The user prompt counter is increased each time the user provides input. Once the counter reaches 3, it checks if the user has previously expressed interest in a cybersecurity topic. User expressed interest equals true. And if the topic is stored, user interest topic is not null or empty. If these conditions are met, the chatbot randomly selects one of the remembered topics from remembered topics and displays a personalized message like, as someone who is curious about topic, this is particularly important. This helps the chatbot naturally bring up a topic the user was previously interested in, creating a more intelligent and engaging conversational experience. After delivering the message, the counter resets to 0 to allow future recalls. Sentiment detection is performed by scanning the user's input for keywords stored in a dictionary called sentiments, where each key is an emotional word such as worried, confused, or scared, and each value is a corresponding supportive response. It uses a for each loop to iterate through the sentiments.keys and checks if input.contained sentiment to find a match. If a detected sentiment and detected topic are found, it prints an epithetic message using type response. Then it sets the current topic to detected topic and uses a random object to select a random reply from responses array, which is then printed to continue the conversation in a helpful and context-aware way. Lastly, I've created a simple chat logging mechanism that saves the user's input to a text file and occasionally notifies them. It uses a static integer variable input counter to count how many user inputs have been made, and a static string chat history path that stores the file where the conversation will be saved. The logged user input method takes the user's input as a string parameter and does two things. It increments the input counter each time it's called and appends the user's input to the file using file.append all text. Additionally, every third input, it prints out a message using type response to inform the user that the chat history has been saved. Thank you.